Hello. So today we are solving a daily question of Leetcode. So the question is walking robot simulation. So it describes that a robot is walking on infinite xy plane starting at point 0, 0, that is the origin, and initially it is facing north. The robot can receive a sequence of these three possible types of commands, that is -2, that is turned 90 degrees, -1 turned 90 degrees right, or the third one is a value between 1 to 9, that is k. When it is a value is given between 1 to 9, it will move k units in that direction in which it is facing at 1 unit at a time. So, and also some of the grid squares are obstacles. The ith obstacle is at grid point obstacle xi comma yi. That means that there may be some coordinates where we have obstacles. So what happens when we have an obstacle? So it is given that if the robot turns into an obstacle, then it will instead stay in its current location and move on to the next command. Okay, so when if it encounters uh, an obstacle, then it won't move in that direction. It will wait for the next command, and if the next command it's again in that direction, then again it won't move because it is currently hit with an obstacle. Consider that you're walking on a road and you are facing a wall. So you have to change your direction until and unless you won't be able to move forward. So in that direction, even if you're getting a number of k values, you won't be able to move in that direction. So you need to change your direction. That -2 or -1, either of these option will be given until we'll stay in that position. Okay, and let's check what we need to return. So it says that return the maximum Euclidean distance that robot ever gets from the origin, that is the distance is 5, return 25. Okay, so basically what it needs is Euclidean distance from the origin, that is what is the current position it's having. So that position with respect to origin is just the square of the x coordinate plus square of the y coordinates, and that is the Euclidean distance that we need to return. Okay, so let's quickly check that north means in positive y direction, east means in positive y direction, south means negative y direction, and west means minus x direction. There can be obstacle at 0, 0 also. So this is can be tricky. Like, there is obstacle at 0, 0 also. Let's quickly check over the examples. So it says that 4 is given and we are facing in north. So we'll consider that a coordinate, just imagine a coordinate axis and we are at the origin. When 4 is given, consider we are moving on y-axis plus 4. So now after that we are at 0, 4. Then we are given -1. So -1 means that we need to turn right. So we turn right. Now we are facing east. Now another k value we are given is 3. So we will move towards in east direction, that is positive x-axis. So after these three operation, where we lie, we are at 3, 4 coordinate, and the Euclidean distance of that 3, 4 is 3 into 3 plus 4 into 4, that is the square of the current x coordinate on which we are and the square of the y coordinate on which we are. So that is 25. Same another example, but here we have an obstacle. So initially robot starts at 0, 0, then we go 4 distance in the positive y direction, then we turn right, then we have 4 again, but when we move to distance and we get blocked by at 2, 4, so we can't move forward. That is when we made one move, we came at 1, 4, but we can't go to 2, 4 because there's an obstacle. So we'll stay at there 1, 4 until our next command is given. So our next command is -2. So we'll turn left. So turning left means that turning left. So again we face towards north. Okay, and plus 4 is again we keep on moving at 4 distance to the y-axis, so it will become 4 plus 4, that is 8. So we are finally at 1, 8, and Euclidean distance will be square of 1 plus square of 9, that is 65. Similar is the another example, but it will be pretty much straightforward because we don't have an obstacle. Okay, so we quickly check the constraints. So constraints are not pretty much high. So why I wanted to check the constraints, because we are given we can move in the range of 1 to 9, so we can easily check for every k value we are given. If this was high and we have 10 to the power 10 to the power 4 number of operations that we perform, then performing that sequentially would give us TLE, because that would be take up a very long time to process. But since it is 1 to 9, so it is very pretty much simple and it can be processed in the given time constraint. So this is what I have. Again, I have currently taken current x and current y, that is currently where we are lying for the coordinates x and y, and answer 0, that will the final answer that we will be returning. Currently it is 0. Okay, what I did is I maintained a pair of I maintained a map of key as a pair that will be the x and y coordinates. And what these x and y coordinates, they are basically the obstacles. Why I want? Because I wanted to find that whether the current position on which we are is an obstacle or not in log of n times. I didn't want it to again iterate over all the obstacles in order to find whether the current position on which I am is an obstacle or not. So that is why I took it in the map, so that I have log of n complexity here. Then I did the the obstacles coordinates into the map, and I maintained a character ch, that is representing in which direction we are facing. So currently we are facing in north direction. And then what I did, I just iterated over the commands. Let's see. So if we are given minus I, so as per the question, it says that if we are given I, turn 90 degrees right. So if we are facing in north direction and we are given the command minus I, we will turn to east. Just need to visualize it, and it is a pretty much straightforward and simple question. Similarly, if we are facing east, its right will be south 90 degree will be west, and west 90 degree will be north. Okay, another is if we are given k as -2, we need to turn left, so it will be anti-clockwise. Now if we are facing in north, 90 degree right will be west. If we are facing as west, 90 degree right will be south. And if we are in the south, 90 degree right will be east. And if we are in the east, then 90 degree right will be north. So this is when we are given -1 or -2. So these two cases are covered. Another case is that when we are given the value between 1 and 9. So first thing what I did is I check for in which direction I am facing. So if I am facing in north direction, what I will do, I just increment the current y axis. What I did, I just iterated from 1 to I, that is the value k, and then I checked for the current value, the value I'm updating, whether it is in the map or not. So if it's not in the map, that means we don't have an obstacle. But if it's in the map, that means there is an obstacle and we can't move forward. So I just break out from there. Otherwise, I keep on incrementing the current y axis. Okay, similarly I did for west. So if we are in the west direction, what we will do, we will be decrementing the current x-axis we have. Similarly, I checked for the value if it lies in the obstacle map or not. Similarly, I did for the south direction. In the south direction, what we'll have, the current y-axis will be decrementing. And if we are in the east, that is the else condition, that is the fourth one, then the current x position will be incrementing. And after every operation, I captured what is the maximum farthest we have reached, because we need to return the maximum Euclidean distance, not the final one, the maximum what is there. So after every operation, we will calculate that where we are with respect to the start position, and this I'll capture that answer and simply return the answer. Yeah, so that's it for this question. So if you have any queries, or if you didn't understand, please do comment out. Or is there another approach that is more simpler, then also please do comment out, because we'll code and learn. So yeah, that's it for today. Thank you so much.